If we could just introduce the judges to you guys, starting at this end.
Hi, my name is Sandra Bosch. I'm from Brazil, and I'm director of a business magazine about small and medium enterprises.
Hi there. I'm the Chief Technology Officer at Goldman Sachs here in New York.
I'm David Tisch, Managing Director of Techstars in New York, which is the world's largest seed stage accelerator.
Okay. I'm Rob Miles, University of Hull lecturer and competition captain.
Edward Happ, Chief Information Officer at the International Red Cross Red Crescent in Geneva.
Hi, I'm David Connor. I'm the European Director of 3BL Media from Liverpool, England.
Hi, I'm Fiona Wood. I'm from Australia and I'm a burns surgeon.
Hey.
Thanks.
Thank you. Oh, we're on. When you're ready? When we're ready, okay. Well, hello, I'm Anya.
I'm Callum.
I'm James.
And I'm Matthew.
And together we are Team Hermes. We have developed a safe driving system to change driving behaviour and therefore save lives. Our system consists of an in-car device, a phone and a web app. We will take you through the serious global problem of road traffic accidents and the Hermes solution. Callum will describe the in-car device, and James will display our applications that are used to educate the driver. Matthew will provide an overview of the technical architecture, returning to myself to show you how we're going to bring this product forward. In terms of road traffic accidents and the Millennium Development Goals, the UN have declared this decade to be the decade of action for road safety. Why? For example, the FIA say that by not dealing with these road deaths, it inhibits the achievement of the Millennium Development Goals. To get an idea of this problem, listen to the head of research from the Irish Road Safety Authority. Why is that now? Right.
The issue of road traffic collisions is becoming a far more prominent area in the area of public health right across the world. In fact, the World Health Organization, in their recent publication, has identified road traffic collisions as the third most likely burden of disease in the world by the end of this current decade. And in fact, in their most recent publications, they currently state that road traffic injuries are the second most likely cause of death after HIV and AIDS for our 15 to 29-year-olds.
Everyone now realises the extent of this problem. The leading cause of death of 10 to 24-year-olds, it's not malaria, it's not suicide, it's road traffic accidents. And each year, this causes 50 million injuries. A horrifying 1.2 million people die. And this isn't decreasing. By 2020, this is expected to double to 2.4 million people. Here in New York, there is one traffic accident every 90 seconds. That could be any one of us here. So, this next advert is the extent governments are willing to go to raise public awareness of the problem.
Can't take my eyes off you.
Why are governments investing in such adverts? In terms of economic impact, road traffic accidents each year have a financial cost of $520 billion. Our solution is built upon the globally accepted strategy of the Road Safety Authority. Enforcement is carried out by the police. Our solution is built upon the engineering, evaluation and education pillars. We have engineered a solution that evaluates the driver's behaviour and uses that information to educate and make them become a safer driver. Because the Road Safety Authority research has shown that educating drivers reduces the fatalities on the roads. We plug our device into the car. This device constantly uploads to the cloud information on who is driving the car, how the car is being driven, and where the car is. Our service analyses that data and provides instant feedback to both the driver and the car owner. It allows a third party to monitor the performance of the driver. This could be an anxious parent concerned about the safety of their teenager, perhaps to a fleet manager monitoring the driving of his sales staff. So we've shown you the global serious problem of road traffic accidents and our solution of a safe driving system. I'll now pass over to Callum, who will take you through the in-car device.
We're going to look at what the Hermes device is, how easy it is to use, how it works, and we're going to see a video of it in action. We have developed this smart device, which will plug into any car built since 2000. As you can see, it just plugs into the diagnostics port of the car. Anyone can do it. Its primary function is to identify if a driver is driving dangerously and give real-time feedback. But secondly, and this is something that has never been done before, it is unique to the Hermes system. It is able to warn drivers of dangerous roads. So what is dangerous driving? Well, indicators include hard braking, acceleration, cornering, and of course, excess speed. This device measures all these indicators. It continuously monitors the speed, throttle position, revs of the engine, and the acceleration, deceleration, and cornering forces on the car. Not alone that, but using RFID keyrings, it identifies each driver and linking the driver to the data, uploads all to the Azure cloud. To beep or not to beep? That is the question. Recent studies have shown that voice feedback in navigation systems can be distracting to drivers. So for this reason, the Hermes device delivers all its feedback through simple, universally recognizable beeps. If I am driving erratically, the device gives me a warning, similar to a seatbelt unfastened alarm. This informs me that I am driving outside of safe driving parameters. And not only that, but I know that the car owner or fleet manager has also been alerted. Think about that. Would that not make you a safer driver? Well, we were actually amazed at the effect this had on drivers when we tested it. They quickly trained themselves to stop the device from beeping, resulting in much better driving. If the car approaches a dangerous road, the device delivers a similar warning, giving the driver invaluable time to prepare. So what is a dangerous road? Well, the Hermes system identifies them through two methods. Firstly, we have an API to allow road safety authorities to add locational data. But secondly, and this is the innovative part, back up on the cloud, James's service, which utilizes Bing's spatial data services, finds them itself. If over time a section of road is associated with dangerous driving, then Hermes flags it as dangerous. So now that we know how the system works, let's see it in action.
There you go, son, now, and drive carefully.
Thanks, Dad. I thought it'd be like spying on me, but instead, it's really useful. Like the way it beeps when I come to a dangerous road. And there's no pressure from the guys to drive hard. I tell them, no way, this black box in my car will go crazy, lad. Here, I'll show you. Tell Dad I was showing you. He's probably got an alert on his phone.
The Hermes in-car device warns drivers of dangerous roads and evaluates their driving behavior in real time and gives instant feedback as well as uploading to the Azure cloud for later analysis. Car diagnostics technology allows us to receive real-time information about the car without the use of any external sensors, resulting in a cheap and easily installable device. I'll now pass it on to James, who will take you through the software.
So I'm going to show you our applications, how we use them to educate the driver, and how this education is reinforced to the user's experience. So using the Azure platform, it has allowed us to build 3 powerful apps, 2 phone apps and a web app. Our first is our vehicle owner app. This is designed to give vehicle owners peace of mind, because all the alerts that Callum described earlier can be viewed and analysed here. You can get a detailed breakdown of those views, and you can even see where your car is on a map. Our second is our vehicle driver app. So this gives a driver data about their journey at the end of a journey, while that journey is still fresh in their mind. So they can view their scores and get a detailed breakdown of those scores. Now, Callum has done some really cool work here, and to avoid distraction while driving, data about a journey is only released when that journey is over, which is signified by the key being turned off in the car. Now I'm going to look at the web app. So some of the features we're going to focus on here are our personal scoring, our focused targeted feedback, and how we use Bing Maps to map driving behavior. So I'll just go over this screen here. So I'm logged in here as Chris, and he's one of the guys we've done some user testing with. So when he logs on, immediately he can see his score, and using this graphic, he can see if his score is getting better or worse. Now, research has shown that it's not new drivers, but newly licensed drivers that are the most dangerous. So to avoid this post-license danger period, we show them any dip in their driving performance. We also give that score context by comparing them against the best drivers on the site. We go even further, and we enable Chris to see what aspects of his driving are most dangerous. So in his case, it's his rev control. We also show him a tip on how he can improve his driving. Now, we got some great feedback on this, and it was this feature especially that the users really liked, because it's a simple to read natural language description of how they can improve an aspect of their driving. And in improving an aspect of their driving, they improve their score. And on the Hermes system, a better score is a safer driver. He can also analyze his journeys. So here we can see that the layout of the dashboard, the layout of the scores is similar to the dashboard, but these scores are specific to this journey. We can also zoom in, and we can see that the journey is color-coded depending on his driving behavior. So when Chris comes along, maybe he wants to analyze this journey with his dad, they can zoom in and see exactly what is causing such a low score on this section of road. So in this case, it's his speed. So using the tip that we provide, he can work on becoming a safer driver. Now, we're also aware that 20% of people have some degree of color blindness, and we've used a lot of color in this site. So we've implemented a grayscale theme for the colorblind. So one of the key design goals for Hermes was to develop a super UX. So our system is pervasive. We connect a vehicle owner directly to their vehicle using the Windows mobile phone. So this gives them peace of mind because they know they'll be notified immediately of any abnormal behavior in any of their vehicles. Our system is also human-centric. Other systems monitor vehicles. We put the focus on the driver. Hermes is built around the user to enhance their personal driving experience. We've used a lot of different design techniques throughout the site, but we've tied them all together with vehicle metaphors. We've also used gamification. So we've given scores to journeys and to drivers. Now, initially, we were worried that giving scores would somehow incentivize dangerous driving, but we've solved this. We only compared them against the best drivers on the site. And this also introduces an element of competition, which further incentivizes safe driving. Our layout is simple, with a minimal learning curve for new users. And we've also stuck to the principle of progressive discovery, in that we only show complex or detailed data when it's requested by the user. So in summary, Hermes educates the driver. From our focused feedback depending on their personal data, to our simple-to-read natural language, to how we use gamification, it's all about educating the driver. Matthew will now talk you through the architecture of the system.
Now, to look at our design priorities and the architecture we deployed to achieve them. Our priorities are what we called OSM. The system had to be open, scalable, and highly maintainable. So how do we achieve this? We used the layered approach consisting of loosely coupled components, resulting in a highly maintainable system. At the presentation layer, we've used Silverlight. The great advantage here is that we could reuse components from our web app into the phone apps. The communications here is implemented using WCF RESTful services. The key here is that it opened up our presentation layer to the wide third-party community. Our logic layer is completely built on the Windows Azure platform. This gives us massive scalability and, of course, low startup costs. We store all our data on SQL Azure, and data acquisition is done through the in-car device. So its architecture is based upon a microcontroller running our .NET Micro Framework application. Built around this are components which are widely available and what give the device its unique, innovative features. In conclusion, Hermes is a system which is open, scalable, and highly maintainable. It's a system built to evolve and expand as the product moves along its life cycle, which Anya will now take you through.
What makes this business viable is 4 points. 1, the product itself. 2, the response to the product from the public. 3, the incentive to use it. And 4, our clear vision to bring this product forward. Some of the innovative features of our product is that it focuses on the driver, not the vehicle. It identifies and classifies dangerous roads. Our system is non-proprietary. And the education is focused on the driver's own driving behaviour. This is a photo taken this week at the Irish Consulate where they hosted a reception for Team Hermes. As the response similar to home, they were really excited about the product. The big question, why would anybody want this in their car? The incentive is cheaper car insurance. This is a quote from a massive American-owned Irish insurance company, and they have said this, they've quoted it, they see the value in Hermes. Our roadmap has been structured into 3 stages. We have a clear vision. At stage 1, it's about product adoption. Remember, the more people that use the system, the more lives that will be saved. The challenge is in the route to market. Realistically, have we the capacity to do this? No. So instead, we will wholesale the system to insurance companies, because we have an insurance company interested back in Ireland. And as a part of us being here at the Imagine Cup, we were approached this morning by an American insurance company, and we have a meeting with them tomorrow. At the end of stage 1, we'll have a repository of data, and at stage 2, we will license APIs to car manufacturers so they can integrate it as part of their onboard system. At the end of stage 2, we'll have a wider community of users, more lives that will be saved, and more data. At stage 3, that's when we will transition to become a data and software provider. We will sell data and software as a service, because no other system will have this information. The revenue potential, 1% uptake of cars in Ireland would generate $5 million. The same percentage here in the United States, $375 million. Remember, that's 1%. There are 800 million vehicles worldwide. In terms of cost, this prototype is costing us $300. Mass-produced, costed with an expert, we can manufacture for $80, adding on an additional 50% for wholesale costs. And remember, in-car devices range from $200 to $250. So we've taken you through the serious problem of road traffic accidents and our solution. We've seen how the in-car device provides instant feedback to the driver, and how James's owner app allows the owner of the vehicle to have a virtual experience in the car, presence in the car, and how the driver and web app educates and incentivizes to become a safer driver. Matthew has shown how open, scalable, and maintainable the whole system is. And we've shown how we're going to bring this product forward. Leaving you with 2 points. Each day around the world, 3,500 people die in a road traffic accident. Hermes will reduce that number. Hermes will save lives. We will now take some questions, but if any of you would like to see our device or apps, we would be delighted to show them to you. Okay.
Thanks so much. That was awesome. Great energy. Sort of a 2-part question. Why no true social features within your app? And in terms of gamification, 1 through 10, how do you guys think you're doing in that area?
Could you repeat the question, please?
Why is there no true social features within your apps?
Oh, well, we found initially in our research into gamification that if we started letting people see their peers, so their friends on the road, our initial demographic user is 18 to 25-year-olds, younger drivers, and straight away they'll say, oh, let's see who can get the lower score, and that's what is going to happen. So we didn't want to let people see their friends because that would just incentivize dangerous driving. So we only compare them against the best drivers.
So what about taking it the other way and actually giving out points, prizes, discounts, because the game is layered in, so you get better status with better things, and therefore you can show off to your friends, hey, I'm half my insurance because you suck at driving, or something like that?
Absolutely. So the first incentivization is through the design, it's the gamification. Secondly, it's through the insurance companies. And thirdly, when we actually start to tie ourselves in with advertisers, we see the advertisers offering rewards that we can actually program into this service.
I'm interested knowing that the target group that you're after, what potential problems you'll have with teenagers tampering with the device to try and get around it and drive like they really want to drive?
Well, we came up with a fairly simple solution to this. We knew it would be a problem. So very simply, when the device is unplugged from the car, an SMS is sent to the vehicle owner's phone, and an alert is logged on the system. So that can be seen on the vehicle owner's phone app. They can go in, see on the map where that happened, and they can also see the same thing on the website.
And then that data is also made available to the insurance companies, so they're aware that if the device has been tampered with, your insurance is invalid for that period of time.
Thank you. I did notice on the way through that you said the warnings were similar. Do you get a different tone for speeding as for a dangerous road, or is it just a single beep? I wasn't clear on that.
What actually happens at the minute is it's two very fast beeps as a warning for dangerous driving. That'll continue for as long as you are driving badly. And it's a series of 4 beeps if you're coming up to a dangerous road.
Thank you.
Okay.
Have you thought at all about integration with GPS units and the ability then to integrate voice in with your system?
Yeah, we definitely have thought about that. As Anya was saying, we knew from we realized that we wouldn't be able to push this through, get it into market on our own. So we're looking to partner with device manufacturers such as navigation system manufacturers, car manufacturers, to get into the market and be able to integrate with their systems to bring down the cost of the system even more.
You detect dangerous roads in your system. Is that done by analysing static map data or by getting data from a Hermes system that's been driven down that road?
Yeah, so we have two ways to identify dangerous roads. We have an API which will allow road safety authorities or government organisations to add any data that they know. So say someone has died on a corner because of the layout of it or something like that, they can go in and add that onto the system. But then the service on the cloud analyses all the data we have, and if there's a concentration of bad driving on a corner, then it gets flagged as dangerous as well.
So it's the fact that lots of people brake too late on a particular corner that makes you think that road is dangerous. So you aren't looking at the actual wiggliness of the road, you're looking at how people have behaved on that part of the road and aggregating that data and pushing back the information.
Yeah, and we see as well, once we have more data, what we'd like to be able to do is look at how a driver was driving coming up to, say, a corner. So say if they were driving badly coming up to a corner and they were driving badly through the corner, then it might not be a bad road, it's just a bad driver. But whereas if they were driving well coming up to a corner and then there was a bad section, we'd be able to say more surely that that is a bad section of road.
And you could feed that back to the road designers and get them to change the camber or improve the surface. Okay, thank you, good answer.
So you mentioned, obviously, insurance companies are very interested in this. There's no right or wrong answer, and it's not going to go into our judgment of it, but I'm curious what your reaction to this is. Let's say that they start to use Hermes data to determine premiums that drivers pay. What would your feeling be if they do that?
Well, that is where we hope that they go with this. We will make our data available online to them, that they can plug. So we have consulted and we've been talking to the people in the Microsoft data market. And we plan on having data sets available there so that the insurance companies can plug their on-site software directly into our data, and their actuaries can use that to develop the premiums. Because in Europe, legislation has been recently passed where gender can't be used. So they're constantly looking for new forms of ways to profile users or drivers. And we see ourselves being the people that can provide that data.
Because currently, premium data is correlated to accident history and so on and so forth. But this is behavioral correlation, which can have implications. So you should think long and hard about that a little bit. Curious about, how did you manufacture your prototype?
The prototype, the casing itself, was done on a 3D printer. And everything that's in it is electronic prototyping equipment. So this is the current prototype that we've been working with. And that's our current design prototype for when we go into mass production. So we'd like to be able to bring down the size a lot, and this could just sit on the dash in the car.
Do you want to bring it down?
But would any of you like to see? Yep. Sorry.
Yeah. So you.
See the phone apps?
Yes, that's.
May I ask, or wait?
That's the cable.
Please, you put focus on drivers, on behavior, right? You said that you put it. But young people are more resistant to be controlled. And I would like to know if you have any strategy in terms of marketing to attract younger clients.
How do we propose to attract younger clients?
Younger clients.
Well, firstly, a lot of younger drivers, their cars are owned by their parents. So the parent will be the driver. The parent doesn't want, if any of you guys here are parents, a lot of the feedback we've been getting from parents is they're sitting at home, they've given the car to the son or the daughter for the night. They are afraid of getting the knock on the door that something has happened. So they will push the device on the kids. Secondly, the kids will want it because they get the lower insurance premium. There are our two drivers initially.
Okay, thank you.
Can I ask, how would this work if someone stole your car with respect to your premium?
Well, if they don't plug out the device and you log onto the site, you know where your car is.
Safe.
So you see that it's a positive to find your stolen car?
Sorry?
If your car is stolen,
yes.
and therefore you're not driving it,
yes.
Is that a positive because you'd be able to find your car? Is that
yes.
what you're saying?
Yes.
But there's no personal login that tracks the actual driver?
Yes, we have RFID keyrings. So every driver on the system that's logged on the system has a keyring. So when you get into the car, you have to swipe your keyring and it knows who's driving. So if you drive for 2 minutes and there's no one logged into the car, immediately an SMS is sent to the vehicle owner, and that is also logged on the system, which can be viewed on the mobile phone app.
Thank you.
Well, why did you choose? I'm sorry.
Say my point about premiums. If they don't distinguish the drivers, we'll be in trouble.
Right. Right. Why did you choose beeping? Was it a cost issue, or a simplicity of implementation issue, as opposed to a cheap voice module? Why did you choose beeping?
Well, recent studies have shown that voice feedback in cars can actually be distracting to drivers. And the other issue then was that we wanted to make this universal. So rather than going into every country and having this in every language, we just went with a simple beep that can be deployed worldwide and is easily recognizable.
Do you think that beep is distracting?
Not as much as voice, because it's lasts less than a second. It's there in your head. You don't have to listen to a voice. You don't have to try and think about what the voice was. You know it's a beep instantly.
Does your system detect if the radio's turned up really loud?
No, it doesn't.
It should.
Thank you.
Next version.
You have a figure of 1% uptake will generate these. Do you have a figure for what percentage of insured drivers are in your target age range?
In Ireland, the figure we got from the company was 200,000.
You have a 200,000 customers who would really benefit from this? That's the number of drivers. That's
the initial target audience in Ireland alone.
Okay, thank you.
One more question for me. You know that there's things like OneStar satellite, there's BMW, this technology of transmitting information back, not to the extent you folks are doing. Clearly you are monitoring more variables, etc. But essentially those systems could start doing what you're doing. So in one sentence, if you could describe what would distinguish your product 5 years from now when, let's say, BMW starts to offer similar services?
Our system is non-proprietary, so it will be available to all the systems, to all cars, so it will be able to become a standard in time, and it won't be divided up between various manufacturers. Full stop.
So you wouldn't mind if BMW picked up your protocol and put it into their cars?
We plan on liaison with manufacturers so that we can put our technology in their cars. So if they call us, we'll answer the phone.
And hopefully they'll pay you a lot for that.
I've just got one quick question. Would it be possible to build in detection of mobile use by drivers whilst driving into the system?
Absolutely. Because it's an in-car system, there is a huge amount of features that can be added in. And as we were developing the product, we keep getting ideas from people that can be added to it. We decided to focus on what we were doing with this project for this presentation. It's all about educating the driver and behavior management and modification. And, you know, that's where we want to go with it as it goes on. Of course, with any business model, we hope that as the product peaks and starts going to decline like any product, we can add new features and rejuvenate the product. And of course, all these features can be added in.
Fantastic. Thank you very much, guys.
Thank you.
So, all the hardy folks sticking with the programme, we're back in half an hour at 8 o'clock for the final presentation from Oasis.